So with client-side single-page applications, we have two strategies we can use to implement client-side routing. One is called the hash location strategy, and that's the one we've been using so far in this section. And the other one is called path location strategy. By the end of this lecture, you're going to know the difference between the hash location strategy and the path location strategy. And you're also going to know the pros and cons of each approach and be able to make a good judgment call for when to use each. So to enable hash location strategy in an Angular application, we pass an object with useHash being set to true when we are providing our routes with router module. Now a URL can contain some data prepended with the hash character. This hash part of the URL is called the hash fragment. So it was developed originally so that people can link to a particular section in a HTML page, specifically anchor tags. For example, if we have an anchor tag with a name of routing strategies like the one on the screen right now, then if we created a bookmark like the one on the screen where we do hash and then we provide the name of the anchor tag, then the browser actually opens up that page and scrolls down to that anchor tag so that the anchor tag is at the top of the page. It was a way of linking not only to a page but to a particular section in a page. Okay, that's why this hash fragment was created. However, it has another very important characteristic. Anything past the hash in a URL never actually gets sent to the server. So if the URL we were visiting was something that looks like this, so we're looking at a contact page and then hash foo-moo-loo, then the browser makes a GET request to Codecraft TV/contact only. The hash foo-moo-loo part of the URL is never ever sent to the server. If you were in fact to look at your logs on the server, you would never ever see a reference to the hash foo-moo-loo. It's only for the browser. So another way to think about the hash fragment, since it's never actually sent to the server, is that it's for storing the state of your client application. It's therefore an ideal solution for implementing client-side routing. It's part of the URL, so it can be bookmarked and sent to other people. It won't confuse the server side since the hash fragment is never even sent to the server. And it can be programmatically changed via JavaScript. And that's exactly why for a number of years the primary way of implementing client-side routing was via hash fragments. So taking a look at the application we've built so far, the iTunes application, if running locally, the URLs might look something like this. So localhost/hash search, and the same with the artist URL. But according to the server, it only ever sees one URL. It just sees localhost:4040. The other hash fragment stuff, it's just ignored. The server never even knows about it. That's why we call what we are building a single page application. There is only ever one page requested from the server. And in our example, it's localhost:4040. The other pages in our application are just changes to the hash fragment, which the client application deals with. So from the perspective of the server, the whole site is just a single page. So another strategy in Angular is the path location strategy. This is in fact the default strategy in Angular, and in order to enable it, we need to do nothing. And it takes advantage of a relatively new HTML5 API called PushState. It's from the HTML5 History API. When I say new, it's actually been around for quite a few years now, but relatively new considering the birth of the internet. By using push date, we can change the URL and the browser won't request the page from the server. Let me show you. So to switch on path location strategy, we need to do nothing, which means we need to remove this use hash is equal to true in our router module for route. And then I'm going to just navigate to the home page. And you should be able to see straight away that the URL looks a bit different. We don't have the hash part of the URL anymore. So now if I click on search, again, we don't have the hash part of the URL. And if I search and I click on the user, again and again and again, we're not seeing the hash part of the URL. So the browser isn't actually making any requests to the server. It's all being handled locally, but we're not needing to use a hash fragment. We're using the push date API. So that sounds perfect, right, for client-side routing? We get a URL that looks just like any other URL, so we can bookmark it and share it and so on. And the browser doesn't send the request to the server, so the routing is all handled on the client side. Unfortunately, it's got one really big downside. If we then reloaded the page, or perhaps we've bookmarked a link and open it later on, the browser would make a request to the server. Let me show you. So in our application here, we've navigated quite deep into our application, so artist, and then artist ID, and then tracks. But now, if I actually try and reload this page, we get an error. That's because the server has no idea about this URL. It doesn't know anything about this URL. This URL is defined in the client-side Angular application via our routing configuration. So the server just returns an error. So by using a hash fragment and the hash location strategy, the server never ever needs to know about any application URL. We'll only ever send to the server or ask the server for the root page, and it will only ever return the root page. But by using a path location strategy, the server needs to be able to return at least the main application code for every single URL, not just the root URL. So with path location strategy, we need to cooperate with a server that supports this functionality. And it's possible, and it's actually quite easy to implement a server side like this, but it does require some effort and some cooperation. Now, just as a quick tip, the local development server started with the Angular command line interface does support this functionality. So if you wanted to try path location strategy, it's quite possible and easy to do so with a project started with the Angular CLI. But for us, because we're using a pretty dumb web server to get back to where we were, we just have to go to the root of the application and reload. So when using the path location strategy, we also need to tell the browser what will be prefixed to the requested path to generate the URL. Now we do that by specifying something called a base href. Now at this point, I'm just going to talk very briefly about a project called Angular Universal. So what if we could build an application that rendered the page on the server side, returned that rendered page to the client, and then from that point on let the client handle the routing? So what if we could reload this page, this artist page, have the server call the API, the iTunes API, generate the HTML for the tracks page, get it all rendered correctly, and then return that to the browser. And then from that point on, if I click on tracks, the browser would take over and start performing the routing on the client side. We could do some really clever things like perhaps cache the pages on the server side, so this request would return really, really fast and just give the user just a much speedier experience with your website. This is something called Angular Universal, or generally in the JavaScript web framework space, it's called isomorphic rendering. but essentially it's the ability to run Angular in both the browser and on the server side. So Angular is actually executed in a node environment, and the output of it is just returned as HTML. Now, the big benefit of Angular Universal is that pages can be cached on the server side, and applications will then load much, much faster. But for Angular Universal to work, the URLs need to be passed to the server side, which is why it can only work with the path location strategy, okay, and not the hash location strategy. So to summarize, the default client routing strategy used in Angular is the path location strategy. But for this to work, we need to serve our Angular application from a server that supports requests on multiple different URLs. At a minimum, all the server side needs to do is to return the same page for all of the different URLs that's requested from it. It's not a lot of work, but it does need some cooperation from the server side. Path location strategy also sets us up for a future architecture where we can speed up loading time by pre-rendering the pages with Angular running on the server side, and then once it's downloaded to the browser, the client can take over routing. This is called Angular Universal, and it's currently in development. And we also have the hash location strategy, which just uses the hash fragment part of the URL to store state for the client. It's much easier to set up and doesn't require any cooperation from the server side, but does have the downside that it won't work with Angular Universal once that's released.